Okay, cool. Well, thanks for coming. And we're going to talk about AI-assisted software development on Solana this afternoon. So let me just start by stating that the future of Solana blockchain development will be one where we as developers can use an AI system to perform tasks in software development securely and accurately, to make us more productive and also to improve the quality of our output. What we're going to ask ourselves today is how far we are from that future, like where we are along that journey and how we get there. So I'm JP Marcos. I live in Palo Alto, California, and I'm the CEO of Codigo. Codigo is the first AI software development platform built from the ground up for Solana specifically. I have a background in artificial intelligence. Prior to founding Codigo, I founded a company called Signify. Signify transformed or helped transform the DevOps functions company I started in 2015. And it was eventually acquired by a public company called New Relic. So we're going to dive specifically in the performance of generic AI models in AI software development. So without further ado, let's get started. Let's just start by saying that that future that I described for Solana developers is already there in traditional software development. Like today, 50% of 30 million software developers around the world are already using AI in their development process. And that's up from 0 just 2 years ago. Just to put things in perspective, it takes typically disruptive technologies about 20 years to be completely ubiquitous. Think the PC, the mobile phone, or the internet. For cloud computing, for instance, it took 12 years to get to 50% penetration. Here, we got to 50% in just 2 years. It's a tsunami in terms of adoption. And as a result, the AI coding technology is a massive market opportunity that's estimated to reach $30 billion by 2030. So it's not a surprise that AI coding tools have grown both in adoption and also in numbers. It's a very big market opportunity, but it's also already a very crowded space. However, if you distill it down to the models, right, the models underlying all these tools, there's actually very few of them. It's like all these tools are leveraging a model that's built by OpenAI, Anthropic, Alibaba, Hugging Face, Google. And the leader of the pack, Cursor, for instance, is leveraging Claude by Anthropic. So the number of companies that can afford to train a model for these type of functionalities are very few because it's just a massive level of investment and just a lot of expertise. But the space has sprung up. And what we've determined so far is that AI can code and can code well, otherwise you wouldn't see this type of adoption. But the question is it useful for us? Is it useful in crypto? Is it useful for Solana developers? To answer that question, what we did is we did a benchmarking study. We tried to follow the scientific method as much as possible. So in order to do that, we took obviously one chain, to level the playing field, Solana. We also took the latest models out there, whether it's, GPT 4.0, Claude 3.5, Gemini 2.0, and so on and so forth. Then we applied multiple prompts to all the models, the same ones. And we tried to take the prompt out of the equation. What I mean by that is that if the prompt is too vague or badly formulated, the problem may be with the prompt as opposed to the model. Our prompts were literally 30 lines long. We not only describe a use case in great details, but we also specify implementation, like, what is the data types, what is the function, what is the structure. It's like we really went all in to give the best chance to the model to see what they got, right? So what did we learn? Before I answer that question, who are you or developers, blockchain developers? Okay, so there are a few. So I'm just going to share a few learnings. There were just a lot of learnings, but I'm just going to share the main ones at a high level. So the first observation is that none of the models are able to generate entire programs in a way that would inspire a lot of confidence. When you look at the code, and I have to apologize for the graphics, but we're dealing with code, right? You have to have the ability to read the code, test, compile it. Like that's essentially the output. But when you look at the code in detail, you realize that that code requires significant manual intervention in order to just make it work. There are syntax errors, there are update dependencies. There's just very, very basic things that just are not there. It looks like it's great because it's going to be very fast. You have like that aha moment. But then if you go 1 or 2 levels down, you realize that the code actually cannot be used as is. And you have to work on it a lot. The second very important dimension for us developers is security. There, it's a similar observation. The code fails, at performing just basic security checks, such as defining which account is a signer, or account ownership, or the address length, just very basic things that are not there, and that doesn't inspire very much confidence in terms of how to use the code. And the last thing is broken structure, particularly around account definitions or pub keys. So we can go on around, but the general level of capabilities for those models is that it's really not there yet. We're far away from that promised land of us really leveraging those models in order to be very, very efficient as Solana developers. However, the reality is that those tools are very popular, even among blockchain developers, right? There's a discrepancy there. So how do you reconcile those two? Well, there's a very simple explanation. It's like those models can be used to a certain extent. It all depends on how you use it. And there's a very simple framework here that will help you understand, how you can leverage those tools or not. Think of it as a degradation curve with the size of the project. Tools like Cursor or Copilot are great for microtask. A microtask is essentially correcting a typo in the code or like getting an Excel function. For those, you actually get a lot of leverage and a lot of productivity, right? Those tools are great. You're not yet at the stage where the blind spots are exposed from those models and you start getting hallucinations. The next step would be a modular code block. This would be like a React script, for instance, right? For this, you have to look at the output. It's like if that's what you're requesting, an SQL query for data filtering, for instance, that's what you're requesting, you just have to look at the output. You should expect that you have to modify the code a fair number of times. The next level of complexity would be a single file program. This would be like a single file for a smart contract or an anchor program. At this particular stage, you have to look at the code. You have to expect that you're going to have to do serious manual intervention, and you better know what you're doing. You're starting to get to the stage, in fact, you're already at the stage where it's almost not worth it to leverage those tools. You're better off just coding manually. And the last one is a multi-file entire project. This is an entire project, right, including the front end, the back end, and the Solana program. This is beyond reach of any model at this stage. So how do we get there? The answer is in that quote. Translated it, yes, AI models are getting better and better all the time. This is something that you hear all the time. The models are getting better. But it doesn't mean that they're going to get better for your particular use case. Unless someone makes the effort to train an AI system for the particular use case of the Solana developer, then we're not going to get the benefit of AI, and we're going to be left behind, in particular, relative to our colleagues in Web 2. And that's because the path forward really is for the next AI system to help us to be native to Solana. It's like that's development effort that's done specifically for us. Because blockchain is actually decentralized, it's transparent, it's immutable. Code, most of the time, is money. And therefore, the threshold for security is much higher. It's a completely different programming paradigm, different languages, it's a different workflow, it's even a different technical stack and ecosystem. So unless someone is laser focused on solving that problem and building the technology specifically for that use case, we're simply not going to get there. Now, how hard can it be? Can we do it? what's standing in the way of us getting the same level of magic and assistance as our colleagues in Web 2. I'm just going to give you a few examples to show how difficult that can be. The first hurdle along the way is data. There's massive or extreme data scarcity in Solana. To put things in perspective, there are 1.8 trillion lines of open source Python code, right? Now, if you look at GitHub today, there are about 58,000 repos that are labeled as Solana. Out of those, 10,000 deal with smart contracts. If you test the code that compiles, you're down 20%. You have 8,000. Then you start applying security checks, right? You want to make sure if you're going to train a model that you train based on code that actually is secure, is good quality. Depending on your threshold, you roughly lose 50% there. And that, what remains, represents 0.007% the volume of code that you have for Python. What's the implication? Most of the models are trained using a method called unsupervised learning. Unsupervised learning means that you essentially let the model run its algorithms on a massive amount of data, and the model picks up patterns by itself, right? But you need a lot of data in order to be able to do that. We don't have that luxury. So the only way to do it is to do a supervised training learning method. What that means is that every single data point has to be explained or labeled, right? So in this case, even though we're left with a small number of repos, that's still several tens of thousands of lines of code. Every single line of code has to be labeled. So if you want to train an AI model, you have to go through that process. That takes months. It's just a lot of labor. The second is training the model itself. It's not as simple as, okay, I've got my data set, I've gone through the hard work of training my model, of curating my data set, labeling it, I'm ready to go. Actually, there are many, many dimensions that you need to train the model for. First, the first step, you take that data set and you train it basic Rust. So I understand Solana native, also understand Anchor. A lot of your data is going to be Anchor code. The second is you need to actually teach it what it means to be security resistant. What are the specific security vulnerabilities that are specific to Solana that the code needs to be able to be resistant for? For that, you need a completely different data set. In our case, what we did is we scanned about several hundred audit reports. We created a database of security vulnerabilities that are current. And then we created repos that have those vulnerabilities as well as the fixes. Once you have that, it's another layer of learning. It's called reinforcement learning. And you train the model that you have here along the security. Then you also need to train the model on understanding instructions, specific Solana instructions from developers. So it's not easy. The point is that unless someone is interested in that problem, it's just simply not going to happen. And that's why you have the result that I talked about earlier. And the last thing is, the code itself is one thing, but we're operating within the Solana ecosystem, right? There are things that you need to take care of, such as integration to the light libraries or to the latest Solana tools, and you need to keep that current. Here, you start building specialized agents. You need to have an orchestration layer, and you need to maintain it so that it's always up to date with the latest Solana developments. Those are the type of hurdles that you need to go through in order to make something work. So obviously, I'm here because that's our life work. That's what we're doing with Codigo. I wanted to give you a preview of the work that we're doing, and also to let you know that we're live. After 2 years of hard work, we released our beta about a week ago, just in time for Solana Global Hackathon, in case some of you are participating to the hackathon. It's packed with a massive amount of functionalities. You have the ability to leverage an agent in order to start developing from a prompt. You also have a library of templates. You can also import your code from GitHub and leverage a Copilot assistant that's specifically trained for Solana, that's best in class today, and start essentially just getting the same type of leverage as your colleagues in Web 2. We also have a roadmap that's very ambitious, and we're going to evolve this platform to bring it at par with the best tools in the industry, and that's Codigo. I'm hoping that you've taken something away from this presentation, which is be careful when you use generic AI tools. I hope that you're going to give Codigo a look, a shot, and that you're going to follow us. But in the short term, if you're a new project or an existing company, you're still working on your Solana programs, or you're participating to the hackathon, you can get a lot of leverage in the short term by contacting us. Message us directly and we'll set you up on an account. We also want to take you to mainnet if you're not participating in the hackathon, but you're simply just building your project. And besides an amazing platform, you have a team of Solana experts that are going to be every step behind you. And we just, are launching, hoping to transform the Solana ecosystem. That's it for me today. Thank you very much for coming.